Utkarsh is also invited from the Hong Kong U Developer Student Camp. He will going to share about intermediate level topics about JavaScript promise. If you have already touched in the JavaScript and then maybe you are interested in this topic, it is suit for you. Hello, Utkarsh. Okay, then I pass the time to you. Thank you, Utkarsh, for supporting us. So, yes.
Hi, thank you so much, Emma.
Thank you.
I hope you're able to see my presentation. So in today's talk, I'm going to be talking about promises in JavaScript. It's an intermediate level. I'm hoping that some of us are JavaScript developers here and they understand a little bit of JavaScript. Here in this talk, actually, I will not be talking directly about promises and how to write the code itself, but more about developing into the idea why promises are important and how we can make them into useful tools for programming. So most of this talk is going to be about a little bit of background of how JavaScript actually runs under the hood, and then how promises can be leveraged to make things really easy for us. So okay, let's get started with the basic stuff. We all know that JavaScript, or at least have heard that JavaScript is single-threaded. What that actually means is that there is a single call stack in JavaScript. Now, this on the left is a sort of representation of a call stack. It's just a stack of all the functions that are being executed. JavaScript picks them up one by one and executes them, just as a single-threaded programming language would do. If you do not identify that as a call stack, I'm pretty sure that you will identify this as a call stack. As JavaScript developers, we've always come across errors, and whenever there's an error on the console or on the browser window, you'll see this long list of functions that you've probably called in your code, and it'll tell you, okay, where exactly the error happened. So as you see on the right hand side, we have this call stack of functions. So both of these are actually very equivalent. Again, since JavaScript is single-threaded, this also implies that code can be blocking. What this means is, let's take an example of these two function calls here. Let's ignore whatever we know about HTTP requests in JavaScript, and let's say that the first request will only pass and go to the next step once the first one finishes completely. So what would happen here is, when the first GET request to that URL is made, it would wait for that to finish, get all the data, and then move on to the second line. Now, as programmers, you would identify that that is not good, right? We don't want blocking code, especially if they're independent of each other. Even in other programming languages like C, C++, and Java, we usually make separate threads or coroutines to handle these kind of operations on a completely different thread, so that they can happen sort of parallelly. Well, in JavaScript as well, there is no multi-threading, but I think everybody knows that that is not how actually HTTP requests work. They work asynchronously, and we can actually run them not parallelly but out of order. And that usually is done by something called the event loop in JavaScript. And also there's also something called the task queue and a runtime API, which is a sort of black box you see on the right there. But let's just keep it simple. Let's just keep an overview so that we can have like a simple understanding. What I'm going to try to do here is walk through the script that's on the left and sort of try to make sense of what's going to happen whenever a JavaScript application is run, and how these runtime APIs, task queues, and event loop like sort of come together. So let's say a script is run on the left, right? So our call stack has the main script running, right? So when that main script is running, our code runs on a fall down sort of approach, and the first set timeout is encountered. Now again, if you're well aware of how JavaScript works, you would know that set timeout is an asynchronous call. And this asynchronous call is actually not magically just handled by JavaScript. It's provided by these runtime APIs. Now, I think it's a good time to explain what this runtime API actually is. This is usually either your browser, if you're running a browser-side application, or Node.js itself, if you're running sort of a backend application. And both of these platforms independently provide some sort of APIs in the background to handle such asynchronous calls. What these runtime APIs do is basically they provide multi-threading. So even though JavaScript itself, the call stack, is single-threaded, the runtime APIs sort of do some magic in the background and isolate all of that stuff from the user. So what happens here is after set timeout appears on the call stack, it magically disappears. Well, we say it magically disappears, but it has been taken up as a task by the runtime API. Now, the set timeout has a callback function in it and a time limit. The time limit is in milliseconds. We say is 1,000 milliseconds. So the runtime API actually starts a timer in the background, and it says, okay, after 1,000 milliseconds, I'm going to do something to run this callback function. What is that something? Let's get to that later. Because right now, our call stack is back on the script. Now, since it's back on the script, it sees the second timeout. And then again, just like the first set timeout, it magically disappears from the call stack. Now, the runtime API, which is running sort of outside the JavaScript engine, has probably finished the first set timeout. The timer has finished 1,000 milliseconds. So now it decides to do something about that callback, right? So now it can't jump back directly into the JavaScript engine and go that, okay, now run this callback. Instead, what it does is it pushes that callback into something called a task queue. Now, when it pushes that thing into the task queue, it's you can imagine this task queue is like a queue of callbacks or just functions that need to be run sometime in the future. So we'll actually see that since both these timers are 1,000 milliseconds, these both callbacks appear on the task queue after a second. Now, this is where actually the event loop kicks in, because now our script is finished, right? So now when the script is finished, this event loop is actually the thing that's sitting there, looking at the call stack and saying, is the call stack empty? And if the call stack is empty, it'll take tasks from the task queue and push them on the call stack to be executed. So just like here, the event loop goes, yes, the call stack is empty. So it's going to pick this task, the first callback, and it's going to execute it. And when it executes it, it's going to give us a console log output after 1 second. Now the event loop goes, oh, the call stack is empty again. So it's going to do the same thing for the second callback, right? And basically, it's going to, again, run this. The call stack, the JavaScript engine is going to run this callback function, and it's going to make the call stack empty again. We're going to see a console log out. So I hope what I've done here is sort of giving you a vague idea. While I'm keeping the details really out of this picture, this is vaguely how our asynchronous calls work in JavaScript. So again, JavaScript is single-threaded, right? Let's wrap our heads around what just happened. We had 2 set timeouts. The program waited for 1,000 milliseconds for each of those set timeouts, and we run the program, and it gives us 2 console logs after 1 second, right? But I think there is a key question that we ask ourselves here. What's the time difference between those 2 set timeout console logs themselves? It turns out that, and if we understand the mechanism we just went through in the last slide, that it actually does not take any time at all to print between the 2 console logs. And that's basically because there is some magic happening in the runtime API, right? It's running these timers sort of concurrently so that you can get this asynchronous behavior of JavaScript. Again, to just reiterate the idea of the concept that we just discussed, again, JavaScript is single-threaded, right? Which means that even if one of those callbacks that go into the call stack are blocking, there is no magical way in how the JavaScript engine will move on to the second callback of the set timeout. it's going to wait for the first one to finish. So JavaScript inherently is single-threaded, right? So now we get some pros, some cons of asynchronous programming. We understand how like code blocking works. We've got a glimpse of how we can block our code even when having asynchronous code. So we sort of understand that we have to handle these asynchronous tasks, right? And these asynchronous tasks are nothing but this callback functions, right? The orange in this upper one and the green one, the lower one, these are basically callbacks, right? This is what we are calling callbacks. So now callbacks do exist, right, to handle these sort of asynchronous tasks, but we need a better way to handle these things. And there is a very good reason for this. Let's just imagine like we have a request to an API, and then we make a call to a database from the data of that API request, right? Which means we want that API request to pass, and then after that, we want the data from that API request, and we want to make another request to the database. And in the process, we want to handle any errors that can occur and make sure that we are not sort of violating any data fields on our database, for example, or all of that handling has to take place in a very synchronous manner, right? So again, we do have callbacks for all of these things, and before promises existed in JavaScript, callbacks was how developers did it. But I think callbacks lead to a very difficult to understand code, which is very famously called the callback hell, right? And this is very ugly looking code. I've taken this from callbackhell.com, and it sort of reiterates the idea that callbacks can get really ugly to read in the future. So this is why actually I'm trying to build that promises are needed. Right? So when I look at promises is basically an object, and when I look at that object, I know that it will have value in the future, and that's all that's there behind the concept of promises. That if we can somehow manage these values that come after a while asynchronously, if we can manage them in a better way, we have a solution to callback hells, for example. Let's first take a look at the code, and then I'll sort of try to break things down of how a promise works. So basically, a promise is created using the promise constructor, and this promise constructor has an initializing callback function. Does not have what this basically means is that it takes a callback function as an initializer for the object. And as an object, it has 3 states, right? One is the pending state, where the initializing callback is still not considered to be complete, but it's also not considered to have failed, right? And the second state is the fulfilled state, where the initializing callback is sort of considered to have completed successfully. And the third state is that the callback is considered to have finished unsuccessfully, or it has failed, right? So again, how do these promises sort of attain these states? Well, that initializing callback actually has 2 arguments in it. One is the resolve function, and the other is a reject function. You usually see them as resolve and reject in code conventionally, right? But the idea is that these 2 are actually functions, right? And by default, when you create a promise, it's in its default or pending state. But whenever the resolve function is called from within the initializing callback, it enters the fulfilled state, right? And whenever the reject function is called inside the promise, it enters the rejected state. And these functions can only be called once, and only one of these can be called within the initializing callback. So now we know that promises have states. They have this constructor that takes the initializing callback, and they can change their state according to how the promise, the initializing callback executes. Let's take a look at what this looks like. Right? So here, the set timeout is an async callback, which is sort of emulating how an API request would go, right? And basically, this is the syntax, right? That you put an initializing callback, which resolves after 1,000 seconds. So that resolve function is being called with a value inside of it. which basically means that this promise object, when it's initialized and it enters the fulfilled state, it's going to have this value in it, right? And to make sure that we know that this promise is resolved, there's a .then function, right? And this .then function is basically attaching a handler to this promise that says that, okay, when this promise is fulfilled, take whatever value this promise has, and basically, again, inside then we give a callback as to how to handle that value that has been resolved for the promise. And something interesting about this .then function, just to sort of get you started with promises, you'll see this convention around where we just chain a lot of these .then functions together. Now that is possible because the .then by itself returns a promise as well. And that promise is resolved when the first .then returns a value, right? And this value is passed on as a resolved promise to the next .then, and then again, we can get the value out from there. And finally, there is a catch. Not literally a catch, but a catch function in JavaScript, which basically attaches an error handler to these promises. Whenever a promise is rejected using the reject function, for example, or a chain.then sort of throws an error, we can handle that error using this .catch. And it's very similar to all of the syntax that we've seen. We give it a callback with the error value as the argument, and then you can handle the error however you want. And then finally, async await sort of makes all of these things very simple, right? What this means is that you can define your own asynchronous function, and you define, okay, so let me actually walk through this code with you, right, to sort of reiterate the idea of what's going on. So again, we define a function, do something which is asynchronous, right? And do something is called, it goes up, it awaits for a new promise. What that basically means is that wait for this new promise to get resolved. So now this asynchronous function does not really stop here, right? It's similar to set timeout. It's gonna go magically await somewhere else, and then it'll print console log finished. And after that promise is resolved, that is after 1,000 milliseconds, it's sort of gonna just console log do something async. We can actually see that in action here. When I run the script, goes finished, do something async, and yeah, there we are. So maybe I can try to recap whatever we just saw right now using a simple example on code itself. I hope my screen is visible. So I actually built a script beforehand to sort of reiterate and sort of summarize the whole idea of what we discussed. I hope I still have some time. So let's just run down, do a dry run, and see what happens. So firstly, console log, entering script. When we execute the script, that's the first statement that comes through. We declare a promise. This promise sort of gets initialized using this callback. So what happens is it goes to a set timeout. This magically disappears from the call stack, just like before. And we see a console log promise initialized, right? This is the second console log. And then after that, the set timeout is somewhere maybe waiting in the task queue, but it's definitely not on the call stack, right? So the call stack continues to here. So what we see is a pending promise being console logged here, right? Because this promise has not been resolved just yet. And then we get a console log promise declared. And there's a definition of main function, which is still not executed, right? And then this main function gets executed. We attach a handler, a chained handler, to be honest, with the promise, and then we console log finished, right? Which is what we get here. And then interestingly, the call stack is empty. So the event loop kicks in, takes the set timeout if it's there inside the task queue, and it console logs after 1 second, right? And then it resolves the promise. And when it resolves the promise, the handler for the promise kicks in. The first one actually just returns the value, right? So what it does is it resolves the promise for the second dot then, which then actually console logs the value. So we get a #2 hello world. Now, this is just not make-believe. I can sort of try to put a lot of people here at rest by actually executing it and showing that this is exactly how it works, right? So, so yeah, I hope I've summarized it well enough and concepts are clear. I'd be open to any questions regarding this concept. Thank you so much for listening to my presentation. It's been a pleasure preparing for it. Yeah, thank you so much. Hello. Oops. Hi, Emma, you're on mute.
So, any question can ask in YouTube comments. Promise. So how about Async Await?
Sorry?
How about Async Await? Using the Async Await.
All right. Sure, I can go ahead and share my screen again. I think I skipped running the Async Await script. So I've actually prepared an Async Await script as well, right? And what happens here is what I'm basically doing here is I'm creating a do something function. And what Async Await actually lets us do is sort of create an asynchronous function, just like set timeout, right? And it helps us sort of execute this asynchronous function in a synchronous manner, so that to somebody using this function, it would look like an asynchronous function, right? And also sort of resolve values correctly. So let me actually go ahead and run this before I explain any deeper or take any questions further. What happens here is, firstly, a finish is executed, right? So again, I can walk through this. There is an asynchronous function here that has been defined, and then we call it, right? When we call this asynchronous function, what it does is basically puts this in the call stack, again, magically goes away. It's running somewhere, awaiting for this new promise to resolve. And then the call stack moves on with its script, right? So when it moves on, it sort of goes, okay, I need to print the statement. It prints finished. And after 1,000 milliseconds, when this promise gets resolved, this object is resolved. What await is looking at is whether this promise that I'm waiting for has resolved. And when it resolves, it moves on, goes to console log, do something async. So that's why we see this do something async in the console log. So actually, Async Await is a very powerful tool for creating your very own asynchronous functions, and yeah, sort of handling these promises that are going around in your code in a much more predictable way. Right. And this sort of code makes like life easy in terms of development time, because instead of using those ugly callbacks, you have a very sort of linear code where you can just walk through it and sort of understand, rather than jumping around here and there. So yeah, I hope I have conveyed this point sort of clearly.
I think Utkarsh is explaining quite clear. So maybe the audience don't have other questions. And is there still have some time? If Utkarsh have time, will you also introduce the promise.org?
The promise.org.
Yeah.
Yeah, sure. I can, let me think if I can think of an example, right?
If we still have time and the audience don't have questions, maybe you can demonstrate more if you want to.
Yeah, sure. I can, if there are no questions, I can go ahead and talk a little bit about promise.all. So what promise.all basically does is, let's actually take a look at the documentation first, right? So that even I don't speak something. Oh, man, I'm not sharing my screen, man. Oh, Emma, could you help me bring my screen? Thank you. Yeah. So as you can see here, promise.all takes an array as an argument inside, right? And what that basically means is that instead of waiting for one single promise each to resolve, that we sort of do here. Like for example here with the dot then, we wait for all promises to resolve, right? And I think it's a whole another thing to sort of dive deep into how it's working. But I can give you a little bit of an idea right here, right? So there's something called microtasks in JavaScript, which take the sort of prototype promise and you can run them just like this. And once you do a dot resolve dot then, right? So this is just for one promise when the promise prototype is being used, and then we can just attach a callback to it and say console log or just do some sort of handling here, right? So this is for one promise. Now, the same promise prototype can be used to resolve not just one promise or sort of execute it as a microtask, but also for multiple promise objects. How that is done is like it takes a promise dot, the promise.all takes an argument which is an array of promises, right? So for that, we'll have to create an array of promises. How about, let's create an array of promises. Okay, sure. Let's do this. Right? So we do const promises. Right. And then we do. I hope this JavaScript syntax is not much of an issue. Like I'm gonna just overlook explaining the syntax or how I'm writing the code, just for the sake of time. But right. And then I can just do. Let me see code. And I'm actually going to make a use of async await just for the sake of this presentation, so that I can explain what is going on. And this stuff on top. So you can see, oh, I should have also done this. Let me complete this code and then I'll sort of do a short explanation of what happened. Right. So again, just as we explained, we keep the fundamentals right, and we can sort of understand what's happening here. That there are a bunch of promises that are being initialized here, right? So promise gets initialized one by one, and these promises get resolved only after a second. So the next thing we see, console log promises, and then the main function is called. The main function is called. It's an asynchronous function, which is waiting for all the promises to resolve, right? So we use the promise prototype for this function. Yeah, let's let's ignore the details and just have a sort of, and let's say just come to an understanding that this all is a part of this promise prototype. And what it does is it takes promises, an array of promises, and waits for all of them to resolve, right? And when that is done, basically it's awaiting here. So then the next thing on the stack is going to be this console log, and it's going to finish this console log, which you see here. And then these promises sort of resolve one by one. And I think it would make more sense to have this val printed here to see in what order they get executed. Right. So again, even though all of these tasks probably exist in the task queue, they exist in an order because the first one was initialized first. So it's going to get into the task queue earlier, even though by a fraction of a millisecond, but it's still going to get into the task queue earlier. So it's going to be picked up by the task, picked up by the call stack earlier, right, using the event loop. Okay. And yeah, after this finishes, it awaits, it resolves all the promises. We see that each of them have been resolved with a value before we move on to the next line. So yeah, this promise.all I think can be really useful. I've ended up using this in some of my code where I have a bunch of API requests and I have to wait for all of them before moving on to the next task. Right? For example, let's say image uploads. Right? We do 100 images, upload them on a server, wait for all of them to finish before we move on to the next task. Right? So promise.all can be really useful over there as well. So yeah, Emma, I hope I have made that clear.
Yeah, thank you very much. And now we have got one question. So I'm show on the screen. Here, yeah, you can see on the screen.
How do you handle cancellation with promises or in JavaScript in general? I am not exactly clear about what they mean about cancellation.
I haven't heard about this too. I haven't tried to cancel it.
Yeah, I've actually never tried to cancel it, but this is something new. If it actually exists, I would love to have a sort of a link to refer to this. I'm really sorry that I cannot explain it to you because yeah, I have no idea about it. But I would love to have sort of a link if there is something about cancellation and read about it a bit. And then maybe personally, you could reach out to me using any of my social media and we can have a discussion.
Yeah, yes. Maybe if you have some answer or you have some relative materials about someone study on the JavaScript promise cancellation, you could share to our share to us or share to the GDG TG group, so and all of us can discuss it together. I haven't heard about this too, but maybe someone is doing this. Someone is have a reason to cancel your promise.
Yeah.
Okay, then maybe see any more question. Oh, okay. Then maybe it's the end of this session. Thank you very much. You could find Utkarsh contact in the DevFest website. So welcome to contact him. Copy. Yes. Okay. Thank you very much. Thank you very much, also.
Thank you so much, Emma. Thank you for having me.
See you in future, Yuan. See you. Thank you very much for the presentation.